Hello everyone, this is Prem Kumar, and in this video I'm going to talk about how Pega uses queue processors to abstract the real-time data flow run. We all know that Pega introduced queue processor from Pega Infinity version 8, the same version when the stream processing as well as the embedded Kafka was in. I don't think a video on queue processor is very late, because I still see some projects where they are using agents and they never modernized themselves to using queue processor. So in this video, I'm just going to explain about how queue processor works at the backend. First thing to start is to understand how this Kafka works. Just leave out Pega, think only about the Kafka. Let's say you have a Kafka server. So Kafka, it works with partitions, right? So it can hold some data, some stream set of data, and it is more like a messaging channel. So it means there should be someone producing messages into the Kafka, and then there should be someone who consumes the message from Kafka, right? So this is how the Kafka works. So it's more like a producer consumption model. Till Pega 7 version, Pega was using agent queues. So whenever an instance needs to be processed at the backend, they save the entry into the DB table, and then a background process act on those instances, and then it processes at the backend. So this is how Pega was doing this background processing using standard agents till the Pega 7 version. But with Pega 8, Pega wanted to use this Kafka data process. So what Pega did is, the first step, Pega embedded the Kafka into the stream servers. So it means in a cluster, for the nodes which are classified as stream, they were running the Kafka servers. So instead of processing the data from the DB at the backend, Pega wanted to use the data or push the data to the Kafka server and then process the data at the backend. Okay, now Pega chose Kafka as the server that can hold all those messages. Now think of how Pega can process these Kafka data. If you leave out this queue processor, normally if there is a requirement that you want to consume the Kafka messages from some Kafka server, the first thing that comes to your mind is to create a Kafka data set, right? So you will be creating a Kafka data set, and then you can also create a data flow with the input as Kafka data set. So a data flow can be run, so that inputs the Kafka data, and inside the data flow you can do whatever processing you want. So that will be a normal design definitely from anyone who works with Pega if you want to consume Kafka messages. That is the same design pattern what Pega also implemented for the queue processor. But for queue processor, you have to act as both producer as well as consumer of the Kafka messages. When I talk about producer, someone has to push the Kafka messages to the Kafka server, right? That is what queue for processing does. When you use the queue for processing method, Pega at the backend, they use the Java class, they act as Kafka producer, they pushes the Kafka messages Kafka server. I already explained about this in one of the previous video. I clearly explained you using the PY process notification queue processor. So you will see that there is a message getting added to the partition. Okay, now the message is produced and it is pushed to the Kafka server. Now you have to read the data from the Kafka server. So Pega needs to use some kind of data flow, and let's say if Pega asks you to create data flow, instead of creating queue processor, create your data flow, create your activity, include the shapes, and they can definitely ask the developer to create those data flows, but they wanted to make it more in a low code way. So what they did is they just created an abstraction layer over the data flow. They call it as queue processor. So if you take queue processor is a rule configuration, but it's not a rule. It's not that queue processor takes care of everything. Queue processor never directly processes the Kafka messages. But with the configuration in the queue processor, there is a data flow that is running that takes the configuration of the queue processor, that takes the activity name from the queue processor, consumes the message from the Kafka server. So at the backend, data flow, a real-time data flow will be running for all the queue processor that does all the heavy lifting work. So whatever you want to do with the queue processor, Pega takes care of it. Pega creates a data flow run at the backend, and it will be a real-time run. So whenever some messages get pushed to the Kafka server, that data flow will take care of processing using all the configurations from the queue processor. This is on a high level understanding. Let me quickly show you from the Business Studio so you'll also understand much better. So here I have logged in into the Business Studio, and I'm going to use the same example, PY process notification. Okay, so this is the queue processor that is enabled. It is running on background processing node type. It is configured to be immediate, and the activity you can see P is the process notification. So this is the configuration, but how this queue processor work is, it will have a data flow run. If you go to pega-dm-decision data flow-work, just open the instances. There you will find there is already an instance running, PY process notification. Just open the instance. So here you see the real-time data flow that is running, right? For the last 3 days, continuously it is running in progress, and You'll not find much details. You will just see input output stage. Take whatever data flow run that is associated with the queue processor. For example, POI send email, you will also find this input output stage. So if you want to consume the Kafka message, what you must have done is you should go to records, create data flow, and then add 2 stages. First stage as Kafka dataset, second stage as like running an activity, right? So that is what Pega is doing at the backend. In the source, they are having some data set to read the data, and then you can just think it of like in the destination, they are executing the activity. Okay, now you have queue processor that is tagged to background processing, where this data flow runs. If you go to the run details, there you will find it is also running on the same node where the queue processor is configured. Because you say queue processor to run on background processing node, again, you just abstracted. At the end, what you are saying is you are asking the data flow to run on the background processing node. So data flow runs on the same configuration which you do it in the queue processor. So it runs on the background processing node. One more interesting configuration is in the queue processor when to process, immediate or delayed. So just a simple concept. When you want to push your message to the Kafka server, immediate, if you want to quickly process, you do an immediate push. So Kafka processing, data flow runs, immediately real-time processing will happen. But if you want to make it a delayed manner, you can use the option, you can queue for processing in a delayed manner so that it gets saved into the DB. When the right time hits, the message will get pushed to the Kafka. Only that time it get pushed to the Kafka. As soon as it pushes to the Kafka, real-time data flow, process it. So that is all at the back end. Kafka and data flow is running behind the scenes of queue processing. I can go to clipboard and then try to check the PY work. So Pega creates a case instance at the backend, and you can see all these PY options, whatever you saw before, right? It is running in the background processing, and the run type is also a real-time processing. Okay, now how you can stop this data flow? For now, it's not enabled, but there you can easily hack to stop it. But normally, this data flow is tagged to a queue processor, right? Let's say now if you just do a save as into your own rule set, just stop this queue processor. As soon as you do a save, this data flow run will be stopped. You see, right? It is getting stopped automatically because it's a real-time processing, and it will be stopped for sure. So when you are debugging queue processor, at the end you can also have a look at the data flow run, how it is running, how it is processing. Is there any kind of error? All these things you can also look into. I hope now you got the picture. Your queue processor is running on the background processing. It means your data flow is running on the background processing, but it can connect to the Kafka server, which is there in the stream node. That is where mostly the data will be mounted. But Pega cluster can always reach to this Kafka server or the stream server where all the queue processor or the queue entries are available. So that will get processed. And there are other supporting tables as well. A good example is PR data, decision, data flow, partition table. There you can find how many records are processed, and all those metadata get saved into the DB. I hope now you got the picture how queue processor work at the backend. So when you think of queue processor, you just need to think of how Pega abstracted the real-time data flow run by using a simple queue processor configuration. See you in the next lecture.